Hello, everybody. Welcome to Mr. Herder's Physical Science class. Today we're going to be talking about properties of fluids. So the first thing that we want to talk about is what is a fluid? Most people, when they hear the word fluid, automatically think of a water or a liquid. But in physical science, in science particularly, we try to have a clear definition for what something is or is not. In this case, we define fluid as anything that can exert or transmit a force. So we can either push on something by itself or it can transmit an energy through it. Okay? So one of the things that we can look at is a jack. And it shows here there is a hydraulic reservoir at the bottom down here. And then it has a pump which can pump up, and then it pumps up to this lower upper chamber, which actually has the jack body which lifts your load. Now we can see this, that there's a liquid, and this can exert force. That's how jacks work, is the fluid itself exerts the small amount of force down here to a large amount of force up here, which is how you're able to lift a car by just moving your hand up and down a few times. The second thing we need to think about, though, is air or gas. If you ever played around with these little sumo suits or the bouncy things that you sit in like these guys have, you know that if one person jumps into the other person will go flying. And that is because the force of the person impacting the other one is transmitted through that gas. So fluids are not just liquids, but they are also gases. So again, just make sure you know the definition of a fluid is anything that can exert or transmit a force, and you will see that again here. And the next thing we're going to talk about is buoyancy. What is buoyancy? Well, the word buoyancy comes from the word buoy, which is something that floats on the water and is used in the shipping and maritime scenarios. Buoyancy is the ability of a fluid, which is, remember, a liquid or a gas, to exert upward force on an object immersed in it. Again, here is the definition of fluid in red. That's probably important. It is a liquid or gas that exerts forces. So buoyancy is the ability of a fluid to push up on an object that's immersed into it. Okay? So buoyancy is affected by weight and by density. The heavier something weighs, the more force it takes to push up on it. Okay? And the way that buoyancy works is how an object floats, is if the weight of the water displaced is equal or greater than the object's weight, the object will float, which is how a lot of boats and all the other things like that that float in the water work. The mass of water that it pushes away as it sits in the water is greater than the mass of itself. Um, and when you think about it, what are ships full of down in the hole underneath the water? They're not full of, like, say, metal. It's not a solid metal boat. It's air. And so that density, that weight there does make a difference. Okay. Archimedes, great guy. We're going to do a lab, but he does. But Archimedes is a great guy who figured out the buoyant force with density. Buoyant force is the weight of fluid that is displaced by an object. The legend goes that he was tasked to find out whether or not the crown the king had been given was made out of gold or not. The king thought somebody cheated him. And so Archimedes, trying to figure out what happened, drew a bath, sat in the bathtub, and as the water sloshed over the brim, he realized that no matter what his size was, if some object that had a different density but the same size would actually push out more water. And so that's how he figured out the whole buoyant force thing. The next thing we'll talk about is Pascal. Pascal, he had a principle and a pressure. Okay. So Pascal's principle is this: when pressure is applied to a fluid, the pressure then is transmitted all throughout the fluid. Think of like a water balloon. If you push on the side of a water balloon, the water responds by pushing out on the other areas, which is why water balloons are kind of fragile when you throw them at somebody. But if you catch it really soft, it won't burst. But if it hits, like, say, just your finger, it'll explode because that force, large force in a small area, is spread throughout the balloon and then it'll pop. So the definition of pressure is force exerted per unit of area. Okay. So the formula for pressure is force, which is in newtons, an area, which is a measurement squared. So it's side by side. Okay, let me move this box over so you guys can see that a little bit better. All right. And the SI unit is a Pascal, which is 1 Newton per square meter. So when we talk about pressure, we talk about pascals in the metric system. In the standard system, we talk about PSI, or pressure per square inch. Okay? Pascal's principle defined down is pressure in equals pressure out. Whatever pressure you put in on a fluid, that is going to be the pressure out, and it's going to go everywhere, which is how our jacks and pistons and all that kind of stuff work. The formula is F1 over A1 equals force 2 over A2. So the force in area 1, all right, force divided by the area, is equal to the force in the second area divided by the area of the second piston, which is why you have a small piston when you're pumping up a jack, and it pumps up a large central cylinder, all right, and that's how that works. Next thing, we have a video, so if you want to pause this recording and go ahead and watch the video, for those of you who aren't in class on the presentation, please do so, and it just gives you a little more information about Pascal's principle. The next principle we'll talk about is Bernoulli. Bernoulli was an Italian scientist, and he dealt with fluid velocity. He wanted to understand how things change depending on how you change the flow, the pressure in that system. So fluid velocity increases when flow is restricted. The other side of that is, as the velocity increases, the pressure decreases. So if you up the speed, all right, the pressure goes down. So here is a model or a picture of how this works. So Bernoulli's principle is where velocity of the fluid is high, the pressure is low. So right here, we've got this large volume of water. If it's going to keep moving at the same pace over here, it has to speed up. And in so doing, the speed of that causes lower pressure. It's not pushing out on the pipes near as much because it's going much faster through. And where the velocity is slow, so it's not moving very fast forward, so it has time to exert pressure on the outside of the cylinder or whatever container it's moving through. It has, therefore, higher pressure. This also is true with air. Don't forget, fluids are also gases, the air around us. And this is how aircraft fly through the air. As the wind passes over the wing, it goes slower on the bottom, which means there's higher pressure. But on the top, you have faster moving air, which means there's less pressure. So what ends up happening, the pressure underneath the wing pushes up, which causes lift, which is how aircraft fly. Here's also a little example of Bernoulli's principle in a chemical sprayer. You might have used these this summer. And how it works is you have the low speed, high pressure gets converted into high speed, low pressure. And because it's a low pressure area, the atmospheric pressure is greater than this low pressure area. So it pushes down the fluid, which goes up to try to equalize this pressure, which then causes the mixture. Okay? A little example on how that works. Next, we're going to talk about is viscosity. What exactly is viscosity? So viscosity is the resistance of a fluid to flowing. All right, it's how fast or slow something moves. And this is basically why things are sticky. Maybe not to the touch outside, but to each other. The molecules want to stay together if it has a high viscosity. They don't want to be separated. They have a very strong bond with each other. So remember, the higher the viscosity, the more resistance to moving. You notice down here there's different grades of viscosity. Notice over here, it's so viscous, none has actually gotten down into the container all the way on your right-hand side, whereas the left side is less viscous, and so it just pours really quickly. And viscosity matters in things like lubrication for your motor, in your vehicle, and other things like that for lubricating purposes. Viscosity is really important, and we'll do a lab on that. All right, and that concludes today's presentation.